everybody, welcome to Algebra Online. Today we are going to talk about slope in a way that we have not talked about before, and it is a rate of change. We're going to take a look at real life examples and apply them to math and slope. Okay, so I want you to understand today that speed is a rate, and it is a rate of change with our denominator of 1. And then we're going to be able to describe real life situations, and you're going to be able to write an equation and take a look at slope on how things are growing in the world around you. So the first thing is, let's go ahead and practice a skill that we have been practicing already, is finding the slope between 2 points. So we have x1, y1, and x2, y2. So y2 minus y1 over x2 minus x1 is our formula for slope. So we have 18 minus a negative 7 over x2 is 2 minus a negative 8. And when we have two negatives, we know that a negative times negative is a positive. So we have 18 plus 7, which is 25, over 2 plus 8 is 10, and that is going to reduce to 5 over 2. Oops, you can't really see that 5. Okay, there you go. Our slope is 5 over 2. Okay, so here is a situation. We have Leslie, we have Kristen, we have Evie, and they have entered a race. Now, Leslie, she begins at the starting line, and she rides at a constant rate of 2 meters for every second. So what is the equation of Leslie's travel? All right, so we can write this because since it's going to be at a constant rate, that's going to be a straight line. It doesn't vary in how she is running, so it's going to be a nice straight line. So I know that I can use the y equals mx plus b, our slope-intercept form. And so I'm going to write y equals right away. And if she rides 2 meters every second, or runs 2 meters every second, so that is how fast she is running or riding, and that is how it's growing, right? That's how the pattern is growing. 2 meters every second, every 1 second, which is rate, right? How fast she's going. She's going 2 meters for every 1 second, which is her rate of change. So I'm going to write 2x. You can write 2 over 1, but it's not needed because we know 2 over 1 is just 2. And it says she was at the starting line. So I'm going to put a plus 0 because if we were to graph this situation, she would start at the origin, 0, 0. Okay, so let's take a look at Kristen. Kristen had an 8-meter head start, and she rode 2 meters every 5 seconds. So I'm going to say y equals 2 over 5. That's how fast she is running, 2 meters every 5 seconds. And then with x, and then she had an 8-meter head start, so plus 8. Evie had a 6-meter head start, and she rode 5 meters every 4 seconds. So y equals 5 meters every 4 seconds. That's our slope, x, and then plus 6. So with that 3 information, can you tell me, do you think who won the race? Do you think it is the person who had the 8-meter head start? It all depends on how fast they're going, right? And that's something that we need to compare. We need to compare slopes, and we'll go ahead and do that. Now, I've already graphed this. Yours is probably blank, so I would recommend pausing this video and graphing these 3 equations that we just found, Leslie's, Kristen's, and Evie's. And so for Leslie's, she started at 0, and the slope is 2, so 2 over 1. So I went up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And I just continued to do that all the way through the graph, so I had a nice straight line. Then for Kristen, I went up 8 because she had an 8-meter head start, and then I went up 2 over 5, up 2 over 5, up 2 over 5, and I just continued on. And then, let's see, last is for Evie. Evie had a 6-meter head start, and her rate was 5 meters for every 4 seconds. So up 5 over 4, up 5 over 4. All right, so if the race was 20 meters long, then who won the race? Well, if you take a look at this graph, the very top of this graph is 20 meters. Our y-axis is 20 meters, and the 20 is the top. And then our x-axis is time, 1 second, 2 second, 3 second, 4 second. So taking a look at that, who won? Well, Leslie won, right? If you take a look, Leslie was the first one. This is time, 1 second, 2 second, 3, 4, 5, 6, 7, 8. I'm trying to look, 9 seconds if I counted it right. She was able to cross the finish line faster, a little bit slower, and this Kristen's much slower. So she was able to win the race, but she started at 0. Well, her slope was steeper. See that? So this larger the number is basically like the faster that you're going. All right, that's cool. So what does even slope represent? And slope is different for every single graph. You are comparing, right, the rise over run. You're looking at, depends on the graph, like this one is the height of a tree in feet. So for this one, this slope represents feet, how many feet per year, right? Because it's rise over run, how many feet per year. So I want you to take some time today and I want you to write this out nice and slow in your notes. So what does it represent? It represents the height in feet per year the tree is growing. Okay, so let's talk about rate of change. Rate of change, since our x's is years of planting, we want to know how much is this tree growing per 1 year. Rate of change is per 1 unit of our x-axis. So we have 2 points that we can look at. We have this one that is indicated at 514, and then we have this one that is 0, 4. So if we take those 2 points, right, 0, 4, and 514, and we look at the x1, y1, and this one is x2, y2. Y2 is 14 minus y1 is 4 over 5 minus 0. So 14 minus 4 is 10, and 5 minus 0 is 5. And this is going to simplify to 2, right? 10 divided by 5 is 2. But I'm going to say 2 over 1 because I want to know the rate of change. What that means, it is growing 2 feet per 1 year. So every year, this tree is growing at a constant rate of 2 feet every 1 year. And that is the rate of change. Okay, so let's do that one again. Or do an example like that again. Okay, so what does the slope represent in this situation? Well, let's take a look at the graph. I noticed that this graph, this line is going down. So the bank balance, the money is decreasing. Whew, I know that. Over time. So it looks like every month the bank balance is going down. That is not what we want. We want the bank balance to go up, but it's okay. All right. So what does this slope represent? Well, this is the money that is being spent every month. Okay, so let's find the rate of change. Let's see how much money this person is losing per month. So I am going to use my 2 points, x1, y1, x2, y2, and y2 is 130 minus y1, 150, back, 150, over, let's see, we have x2 is 4 minus x1 is 2. So 130 minus 150 is negative 20, and 4 minus 2 is 2. And if we simplify that fraction, I have a negative 10 over 1, which means she is spending $10 per month. So let's write that out. She is spending, this is our rate of change, spending $10 per month. right? Negative 10, spending money. Good. Okay, so let's have one for you to try. So here's an example. I'd like you to pause this video. I'd like you to tell me what the slope represents, what it means in this particular graph, and then find the rate of change. All right, guys, how did you do? All right, so the slope represents, let's see, distance, and then you have gas. So that means that the slope is going to represent the distance traveled on a gallon of gas, right? So we want the distance for every gallon. That's what our slope is. So let's write that out. The distance in miles traveled per gallon. Okay, so let's find the rate of change. So I am going to choose x1, y1, x2, y2, and it doesn't matter if you chose the other points to be x1 and y1, we'll still get the same answer. So y2 is 88 minus y1 is 44 over x2 is 4 minus 2, and we have 44 over 2, which is 22 over 1. It simplifies. And what does that even mean? That means that because y is on the top of our fraction in our numerator, that means that the rate of change is 22 miles per gallon. So this car is traveling, every gallon of gas is 22 miles. So we're going to write that down, 22 miles per gallon of gas. Okay, so the last example for today is, can you come up with a real world situation for y equals 3x plus 4? So I want you to think about it. Could be anything. Take your time, pause the video, think about it. I'll tell you mine. I thought, well, if I opened a bank account, right, for money, opened a bank account and I had $4. I put $4 into the bank account, and then I decided to put in $3 per week. And so consistently, every week, $3, $3, $3, $3. And so that would be my real world situation. So if I wanted to know how much money I had in like 6 weeks, right, I would plug a 6 into the X, and then I would be able to find out how much money I have. So that would be my real world example, just because I planned on putting in, right, $3 every single week, and it's constant. Okay, guys, well, I hope you enjoyed today's lesson, and I'll see you next time. Bye.